Good evening. Welcome to DEBAKEY CV Live, coming at you from Houston Methodist Hospital. I am Dr. Stuart Corr, Director of Innovation Systems Engineering for the DEBAKEY Heart and Vascular Centre. I am absolutely pleased to kick off our first ever edition of Innovation on the Loose, bringing you highlights of cutting-edge cardiovascular technology right here, right now. Tonight's show kicks off by looking at exciting new developments in our collective strategy to tackle COVID-19. Now, we're all aware of the COVID-19 global pandemic and its impact on society. We are thankfully become more aware of the importance placed on wearing masks, and we are all waiting anxiously for that vaccine. On a positive note, there are a great deal of people working tirelessly around the clock on new ways and new methods to keep us safe, to keep us working, and to keep us living a life as close as possible to some sense of normality. In times like this, it is important that we remain positive, proactive, and look out for each other. And on that note, I am absolutely delighted to introduce my special guests this evening, who have all, in my opinion, stepped up to that cause. They have gone to great lengths to offer innovative solutions in key areas such as PPE, symptom management, and rapid point-of-care diagnostics. On tonight's panel, first of all, we have Dr. Sarma Velamuri, CEO of Luminare, who have reconfigured their sepsis prevention system into QuickScreen, a COVID-19 screening tool to get employees back to work safe and sound. Secondly, we have Dr. Jacques and Smriti Zaneveld, founders, CEO, and research director of Lazarus 3D, a company who went from providing specific anatomical and 3D printed models for surgical training and education to incorporating the rapid fabrication of PPE into their business activities. And finally, we have Dr. Asma Mirza, CEO of Steradian Technologies, a company who provides a wearable optic solution that completely recreates human eyesight, and have adapted their core technology into a rapid point-of-care COVID-19 diagnostic platform. Some truly amazing things happening here. But before we cut to our special guests, I would like to invite the audience into our discussions. So please submit your questions via web at pollev.com using DEBAKEY as the username, followed by your question, or text DEBAKEY to 37607 alongside your question. So without further ado, let's crack on. Okay, my first guest tonight, Sarma Velamuri. Over to you, sir.
Hi, Stu. Thanks for having me on your show.
No problem, anytime. So I guess my first question is, so background, what led you to the path that you're on at the moment with your company?
Great question, Stu. As I like to say, I'm a recovering physician. So I'm board certified in internal medicine based in Houston, Texas. Most of my work has been on the inpatient internal medicine side. And most of my work has been in the Texas Medical Center, which is the world's largest medical center. A lot of my patients, I think about 80% of patients I saw in the hospital were either on the transplant list for a heart, a lung, a liver, or they had just received a transplant. And my job was pretty straightforward. I'm a behind the scenes guy. I helped knit the team together and keep the patient alive long enough for the surgeons to show up and put the organ in and look like a hero. And that was a great job, loved it. The biggest problem we had was our patients used to develop infections, and we call the body's response to an infection as sepsis, and they used to die of sepsis. So I ended up on a hospital's committee, and the reason today I'm a physician in a software company is I was on this committee for 128 hospitals nationwide to help figure out how we can identify sepsis faster. And I started looking for better software to purchase that we could just plug into the medical record system and would identify patients quickly and help us treat them quickly. While I'm on this search, my friend's daughter ends up in my ICU, and she's 22 years old. And I had requested her to be moved from another hospital to ours for 2 organ transplant listing, lung transplant and liver. While she's waiting for her organ, she develops sepsis. And I go up to the hospital to pay a social visit, and they call code blue on the overhead, which means someone's heart stopped. My intern and resident are doing chest compressions on my friend's daughter. And then, I start doing chest compressions, and 45 minutes later, had to go tell my friend his daughter died. So I looked in the computer, and this is 7 years ago. This is before cloud for healthcare existed. This is before you could take data out of a medical record system and process it. And I look in the computer, and it's obvious to me that everybody did the best they could, but the software failed her. So I came home, I took it as a personal failure, mortgaged the house, and started a software company. And today we have Luminare. Fast forward 6 years, and we help identify and treat patients with sepsis quickly and efficiently.
Wow, that's a very harrowing story, but it's, it just shows your commitment to the cause. Now, obviously your system's called Sagitta, correct? And I believe we actually have a video. We actually have a video that we can show the audience about your system. If you'd like to roll to that.
Sepsis is a medical emergency.
An audio on,
At
please.
the average U.S. hospital, 460 patients a year are diagnosed with severe sepsis. Each patient stays in the hospital for 12 and a half days, costs approximately $26,000, and represents a 25% mortality rate. Let's raise the bar. If your facility intervenes on 2 additional septic patients per day, you'll decrease mortality, length of stay, and cost, saving more than $4.2 million in annual revenue. Luminare's Sagitta Sepsis Screen gives you the power of intelligent, real-time sepsis detection at bedside to accelerate treatment and transform outcomes. Here's how it works. Sagitta combines clinical observation with data synced from your electronic medical record to provide real-time sepsis decision support at bedside. When triggered, Sagitta alerts key staff, enabling rapid intervention to the right patient at the right time and saving an additional 20 lives for every 100 patients with sepsis. Lower mortality means happy patients and happy providers. But what about administrators and researchers? They're happy too. Running continually in the background, the Sagitta Analytics System generates meaningful reports to support sustainable process improvement. Luminare works with your team to deliver sepsis screening that's customized to your hospital and to your patient population. Your patients matter to us, and we know they matter to you. To implement a sustainable sepsis screen today, contact Luminare at info@luminaremed.com. Sagitta, Sepsis Quality Improvement, powered by Luminare.
Well, that's fantastic. I always say that a video does really tell the tale of 1,000 words there. So maybe you can just comment on how does this system integrate in a hospital and maybe cases of cardiovascular surgeries? Where would it fit in, and what's the kind of incidence of sepsis in those procedures?
Great question, Stu. So sepsis in very good cardiovascular facilities like the Methodist is actually pretty rare post-operatively after CABG or after someone's had open heart surgery. You can sometimes see up to a 2% incidence. The problem is when a person does get sepsis and they've had major surgery like heart surgery or transplant, the rate of death is exceedingly high. So about 60 to 70% of people who are immunosuppressed and have surgery can die of sepsis. And the way the system works is rather straightforward. We look at all of the data that's coming out of the medical record system, and then we combine it with data that the nurse is seeing clinically at bedside. So if a patient has sepsis or looks like they're going to develop sepsis, we predict it ahead of time. We tell the nurse it's going to happen. We tell him what to do next. We connect the nurse to the next person in the chain, and that could be the doctor, the nurse practitioner, the physician's assistant, the pharmacy. And we make sure that care happens within 60 minutes of the person being detected as having sepsis. And really the niche that we fill is, there's a lot of alarm systems out there. There's AI companies that build alarms. The medical record systems have alarms. But an alarm going off in a hospital doesn't translate into a person getting care. And so our expertise is in making sure that when the alarm goes off, that the person does get care.
Right, so you've spent all this work with Sagitta, getting into the hospitals, going through everything that needs to be done, everything they train you all for, the TMC Innovation Institute, etc. And then bang, 2020 hits, right? February, March, April, etc., etc. So How do you go from that into QuickScreen, into your COVID-19 application? I'd love to know that story.
It's been a rocket ship ride, I would say, is how we went into it. We were partnering with the Center for Disease Control, where they were showcasing our sepsis product at HIMSS, which is a national conference for healthcare technology. And we were their partners. We were the software guys for infection detection when COVID hit. And the CDC team looked at us and said, hey guys, this is great software. You should really use it as a syndromic surveillance tool for COVID. And we said, okay. And so they instructed us to build a COVID tool, and we did. And 4 days after we had that conversation, we actually deployed to our first hospital in Arkansas. And then 16 days after that, we deployed it to Houston. So 5.5 million people, anyone who needed a test across the numerous zip codes had to basically come through our system and qualify for testing. So we're the country's first syndromic surveillance system. So all of the symptom checkers that you see now are kind of after the fact, but our kind of expertise is in syndromic surveillance for large population groups. Mm-hmm. And so, for example, today we have about 110,000 daily users that use the system in order to be able to go to school or go to work. And we have another 200,000 people that are going to be, on the platform in the next 2 to 3 weeks.
My goodness, so 4 days, took you 4 days to go from that to QuickScreen.
It's like it took us 5 years to get to a point where we could deploy something like that in 4 days.
Wow, that is absolutely incredible. And I'm delighted to let our audience know we actually have a really very high, well-produced overview video of this as well. So let's play video 2. Let's see QuickScreen in action.
It's time to start reopening businesses, but figuring out how to keep your employees and others safe when entering your facilities while meeting compliance and privacy guidelines is a challenge. QuickScreen can help. QuickScreen was developed by the infectious disease screening company Luminare and is the country's first employee self-certification system. It is an innovative COVID-19 screening tool to get your employees back to work safely. Initially developed for the third largest county in the U.S., QuickScreen helps you ensure that every person stepping through your doors, from employees and vendors to customers, has been pre-screened. QuickScreen enables you to easily configure business process flows and search through a historical dashboard. This tool ensures that you've deployed best practices that are in compliance with regulations and have created a safe environment for your employees, visitors, and students. Test drive QuickScreen by Luminare today.
Excellent, love it, absolutely love it. So I guess, where are you now with QuickScreen? What's next? What does the kind of future look like?
So what the future looks like is we have 2 business lines within the company now. We have our hospital workflow system, which is Sagitta, which is Latin for arrow. We built a magical arrow, so to speak, to hit the target every single time. And that looks like, sepsis, pediatric sepsis, heart failure, stroke, workflow optimization. And then we have this entirely new business line of outpatient enterprise health maintenance. So we have all of these large companies and, different verticals. We have schools, we have government contract employees, every which kind of company that you could think of, using the system. And we're getting requests saying, hey, can you use this for syndromic surveillance for influenza? Can you use this for hypertension management, diabetes management? And the latest thing we're just coming out with is the vaccine tool. And we're about to launch that at a 300,000 person county next week, where they're going to dry run with the influenza vaccine. So, if you have 200,000 people you need to vaccinate, you're setting up, vaccination stations at 18 different parking lots across the city. How do you get something like that up and running?
Yeah.
And so we helped figure out how to do it in 5 to 6 days.
When you mention a huge thing there, vaccine, the logistical nightmare behind getting vaccines to people, it's, so I'm so glad that you're utilizing your platform technology at this stage to make that happen. That's essentially what we're going to need to do, So, I guess if there's people in the audience out there that are wishing to get in contact with yourself, what is the best way of doing that? Through your website?
Yeah. So the easiest way to get a hold of us is go to luminaremed.com.
Excellent.
Or you can go to checkforcorona.com.
Superb.
And it'll connect you to us.
Okay. Well, I think at the very end we're going to have questions. So moving on with our next guests, we have Smriti and Jacques Zaneveld. Hello guys, how are you doing?
Great. Thank you
Thanks
so
for
much.
having us.
No problem. Where are you patching in from? Where are you in the world?
We are in Oregon right now on the West Coast.
Oh my goodness. So like you guys just moved there, right?
Yep.
Yeah, absolutely. We moved here about 2 months ago from Houston, Texas, and we're loving it so far.
Yeah, I was going to say, how are you guys holding up with the fires? Were you affected by them, or?
Yes, so it was, you know, that scene from Mars. We lived through it for about 10 days, but it's gone now. So I think the east winds are not blowing in this direction and have spared us, hopefully for the better good. So
Well,
we hope they will not return. But yeah, the air quality here is fine now. But before, I think last week it was toxic. It was
Orange
unbreathable.
skies, like
Yeah.
like the house across the way would look orange, and there was ash literally raining from
Wow.
the sky.
Yeah,
Which
so it's like
combined,
a snowfall, but it was ashfall. Yeah.
Oh my goodness.
which combined with the rest of 2020 was a very interesting scene.
Well, I'm just glad you're safe and sound. You know, I'm glad you guys are safe. So, you know, Lazarus 3D. I mean, I've known you guys for, you know, a few years now, almost 4 or 5 years. I love what you guys are doing. So tell us about it. What is Lazarus 3D?
Yeah, sure. So Stuart, I think you know this as well as we do, that there is a current fundamental problem in the way residents and physicians of tomorrow are being trained right now. When we found out that physicians were learning hands-on skills, like using the Da Vinci robot, for example, on a pumpkin, or learning how to perform complex procedures by removing seeds from a bell pepper or suturing on a banana, it was a no-brainer that this needs to be fixed, and there is a serious need to improve how training is conducted, so that we can improve, you know, the complications and the high rate of medical errors that result from this sort of lack of training.
Because if people are learning on these types of rudimentary models, what it really means is that the way physicians are getting trained is by doing surgeries on patients. And we can see statistically, when residents first start participating in surgeries, there are higher rates of complications, higher rates of errors. So that's something that we're looking to address using these new powerful technologies.
Yeah, so about 4.5 years ago, we founded Lazarus 3D in the heart of Houston, in the medical center. And it all started in our kitchen, where we created the first prototypes of our patient-specific models. So just to elaborate what a patient-specific model is, we take the MRI or the CT from the DICOM files of the de-identified patient. And from there, we create a replica, it's a synthetic replica of that individual's kidney, brain, heart, whatever, with their condition. And this is not done in soft plastic materials. I think, Stuart, you have one of our hearts there. It's actually done in tissue mimicking materials, which allow the physician to cut, suture, and the model bleeds like it would in a real procedure. And you can do all of this with the same tools in the same setting as the real surgery, but you're doing it on a non-human or a replica of your patient. So you're de-risking their actual procedure by improving your skills and your surgical plan before you operate.
Wow. I mean, I don't think I would be too comfortable with having a heart surgery by a surgeon who's practiced on a pumpkin. So I'm really glad that you guys are doing what you're doing. And I've got a beautiful example right here. If we maybe get a camera on there. So talk us through this. How, again, I know you mentioned it briefly, but you know, this is a heart I'm holding in my hand here. Synthetic heart, 3D printed using Lazarus 3D printing system. So again, how long does this take you to make, and what type of data? Like, what's the process for that?
Yeah, so it's a combination of different factors, but we start out by taking in MRI or CT scan data from that patient. We recommend that whatever features you're looking to have reproduced are visible on at least 3 slices in that MRI or CT. And that allows us to really capture all of the details that are necessary for the model that's going to be helpful to the physicians. We analyze that data using a FDA-approved software and generate a computer model. And then the real secret sauce, and we have this process patented, is building it in realistic materials. So we've developed a new patented 3D printing-based approach to build these models. And we've also conducted a number of internal tests and tests with partners on the mechanical properties of various tissue. So using our approach, we can get the shape of whatever's in the patient, and we can also create it in materials that closely mimic the actual properties of real tissue.
Yeah, so the goal is quite different than what a lot of traditional manufacturers do, which is make 1 million or thousands of the one thing. Here we are making individual body parts. So every individual is a snowflake, every condition is different, and no two humans are ever alike. So what we are creating, it's massively customizable, so that the physician can basically optimize their surgical plan. And the heart model that you have, it's just a show model, but we've used our technology to make patient-specific models for things like HOCM or for cabbage procedures, which, as you know, are very complex procedures, or even for pediatric cardiology, like patch placement, etc.
Well, on that note, we actually have a video of one of your hearts that's been involved in a training model. So maybe we can play that for the audience. Video 3. So maybe you guys can talk us through this, like what we're seeing here and what's happening.
So I'm so sorry, but I don't think we can see the video on our end.
Ah, okay, no problem. So is it a mitral valve replacement? What are we looking at?
I believe so, yeah.
Yeah. So again, you know, are you guys looking to integrate this into a kind of like a simulation holder, like maybe like a patient simulator that you can put hearts in different times and things like that?
Absolutely, and we've already built, for example, thoracic models for some institutes in the Texas Medical Center, in fact. And what that allows is for different organ sets to be placed in and provide you a realistic environment. So, for example, when you're doing a thoracic surgery, you have to account for the fact that there are ribs in the way. You can't just go anywhere you want with your instruments. We want to capture that and then customize the individual patient pieces that go inside of that to match upcoming surgeries.
Got it.
Exactly. So it could be everything from like the first incision that is made on the patient for placement, and then the actual procedure that is being performed. All of these aspects can be rehearsed or practiced for a untrained physician before they actually end up doing it on the patient. So the comfort level for the physician is maximized.
So, you know, again, you know, like Sarma here, you've been working, you know, fastidiously for so long making this happen. And then all of a sudden I'm watching TV in February, March, and I see you guys on the news. So maybe we can show that to the audience. Video 4.
Local hospitals are right now thinking outside of the box. A lot of them are looking for that personal protective equipment. As we know, some hospitals are running low on that. And in fact, Bentop Hospital got a large shipment of masks today from a pretty unconventional partner. Here's our Maria
Wait, we just get up and run in 2 seconds.
Our team has been working tirelessly for the last 2 weeks, and we were able to get the first batch here today.
Are they seeing the video?
Local hospitals are
okay,
right
I believe we're having video issues there, so maybe we'll just cut it. So, ladies and gentlemen, so literally sitting at home watching the news there, and all of a sudden I see Jacques and Smriti on the TV, and they are delivering boxes and boxes of millions and millions of masks and face shields and PPE. So, guys, tell us about that. How did you go from making hearts to making the PPE?
Absolutely. Well, in our team, because of our core business, we have a lot of experience both in manufacturing and engineering, as well as connections with some of the top hospitals. So on one day late in March, we had 5 different heads of hospitals, you know, top ER physicians calling us up on the same day saying, we desperately need PPE. Yep. Is there anything you can do? Can you print some? So within 24 hours, we printed a number of prototypes. We got them out to several different emergency centers across the country. We got them vetted and tested. And then when we were looking at this and we were planning, we realized that the need was really large. It was way more than we could possibly address just by directly 3D printing these. So we instantly started cutting metal on some injection molds and got hundreds of thousands of face shields built and delivered to hospitals across the country. And then we also leveraged some of our connections overseas to source FDA-approved masks, primarily for Houston, but for hospitals everywhere.
Yeah, the first time that we were on the news, I think we had just shown up with our first shipment. I think it was about like a few 100,000 masks to one of the hospitals in the Texas Medical Center. And at that time, we saw in real time what was going on. And they had in front of our own eyes taken the boxes that had just been brought in from the trucks and rushed them to the ICUs and to the facilities for their physicians and for their staff and nurses. It was a really dire situation, but I'm really, I think it was a really fortunate experience for us to be in that position where we could leverage our network to raise the capital, to get the boots on the ground so quickly, and to have like the infrastructure for managing supply chain to get everything quality vetted and in time to the hospitals that were in this urgent and dire need. And from like looking at it, thinking back as an entrepreneur, we have never done this sort of like high volume type manufacturing or production or management, right? So we had to learn very quickly. And I think with every second that passed, we were learning like like it was rapid fire speeds of learning from on the go. So that was really cool for us.
Yeah, I mean, I think obviously the sense of urgency which you guys had, I mean, it really came through. I mean, you just jumped to action. You got stuck in, and before you know it, again, you were printing off millions of PPE, saving lives. So it's absolutely amazing there.
And shockingly, I saw an article at the time that was had GE. They had started producing face shields, and they built about 100,000 face shields. We're a team of 4 people, and we had produced a lot more than they had than GE had in that period of time, which I thought was pretty funny.
Well, you guys were able to mobilize just at the drop of a coin. I mean, it's fantastic. I mean, so what's next for you guys? What's next?
Yeah, so fortunately, we were able to address the PPE crisis and the shortages in Houston. All of our clients, the hospitals that we were working with at this time are well-staffed and well-equipped with PPE. So fortunately, we have moved on. So now we are back to our regular operations with bringing the patient-specific models on the market. So some exciting things have happened.
Yeah, so specifically, we've submitted our FDA 510K application for these patient-specific rehearsal models to be used as part of patient diagnosis and treatment. We're anticipating that we may be FDA approved either by the end of the year or Q1 next year. And our next major hurdle is to get the large insurance companies to begin covering this technology. So that next time, God forbid, you have a complex surgery, your doctor will be able to rehearse it ahead of time and operate with confidence.
And and with that said, the other there are 2 coins to medical device, the FDA and the reimbursement. So for the reimbursement, you need the billing codes, and those were actually released in 2020 as well by the American Medical Association. So we think that the future is going to be quite bright and promising for Lazarus 3D.
That's fantastic. Well, again, I'm really glad you guys are able to join the show tonight. And again, we will take some questions at the end. And now for our final guest tonight, we have Asma Mirza, who's is the CEO of Steradian. Welcome to the show.
Thank you. Thank you for having me.
So we would love to know your background. We'd love to know about your direct retina projection system. We do have a video. Would you like that to be played now?
Actually, no, we can play that when we talk about how we pivoted a little bit.
Sure.
So, I have a graduate degree in global health technology from Duke University. So a lot of what my mission and my goals are is taking something that's a very deep technology and making it accessible to everybody. And so oftentimes we see that high tech is only limited to certain people or certain classes or certain countries even. And so one of our goals at Steradian is to take deep tech and make it accessible. So what we were working on and what we're still working on is something called direct retinal projection, which is a fancy way of saying that we can take any image and project it directly onto your retina instead of onto a screen, which is how you look at things in AR or VR. And we were using this for helping surgeons be better at surgery in terms of their precision, their accuracy. So instead of wearing loupes or peering into the Da Vinci, they would be wearing our glasses on their face and they could move their head around. It was ergonomically comfortable, and it would take into account the saccadic motion of their eyes. So we had started working on that, and then the pandemic hit. And all of the research that we had begun, we had to roll it back because now we couldn't go into hospitals. We couldn't talk to surgeons face to face. And what we realized very serendipitously in one of our meetings was that the internal optic schema that you'll see in the video, we could use that to amplify a pathogen signal and be able to detect a pathogen within 30 seconds. And we decided to do that for COVID-19.
30 seconds.
That's correct.
That is absolutely phenomenal. So yeah, let's see this video. This is some amazing technology right here. Video 5, please.
The Rumi Portable Instant Detection System. Here's a side view and a top view. And this is a disposable breath tube. This is how it works. Take a disposable sleeve, put it over the device for protection, insert the disposable tube, and have the user blow into it. When the user blows into it, their air will go through the tube with turbulence and specific airflow, guiding the virus or the bacteria into a disease-specific biosensor for binding. Once the pathogen binds to the biosensor will light up. The green light that you see here are photons that are starting to be emitted. These emitted photons are then projected onto our detection system via our patent-pending ellipsoid mirror technology. Once you're done with the test, a readout will be available, and it can be instantly shared to the public health department or network of choice. Remove the disposable parts, and you are ready for the next person to be tested.
Wow, that is absolutely fantastic there. So yeah, so where are you at the moment with this technology? And again, remind you, we do have some slides if you want to use those. So just let us know.
Sure, yeah. So in terms of our technology with surgeons, that's still in development. We validated a lot of the optics, but the Rumi, which is the detection system, we just finalized the device and we were able to test its sensitivity. And now we are working on the breath tube and making sure that when somebody blows into it, that in fact we can get the particles in their breath to reach the biosensor in the way that we'd like to. So we're really excited to kind of move forward with this, because one of the things that we've seen is, especially before surgeries, right now, doctors are using the molecular test and it still takes about 24 hours to get results. And they would prefer having a quick method that they could have a patient blow into and then get them onto the OR table. The other thing is that we can expand this testing architecture to blood, to saliva, to a lot of other things, and to a lot of other pathogens as well. And from a global health perspective, we are working with a company that can help us with connectivity. So right when you test somebody, you can share those results de-identified to the public health department or elsewhere. So there's a lot of really great opportunities here in terms of being able to get the country back where it needs to be, but also creating accessibility. Because right now, most places that have COVID testing are isolated or around areas that are majority white, and populations that are exploited economically don't have the accessibility that we would prefer them to have. So this would be a really great way to engage in that as well.
This is paramount. You know, we have to roll this out to every single person, okay? And I believe, you know, actually when I first got introduced to your technology, I was actually going through a COVID-19 test myself. And I won't say, what pharmacy I went to get it, but it was, it can be quite invasive. This wasn't somebody coming to the car and doing the nasal swab. This was them giving me like the swab and asking me to do it myself. I'm like, I'm not going to stick that up my nose 3 inches,
right.
So I went somewhere else. So something like this is perfect. It's very easy to use, very user friendly. You get results in 30 seconds. I mean, it's fantastic there. So tell us about. We've not really discussed anything to do with like the EUA, so the FDA emergency use authorization. So are you using that as a pathway to bring this into the clinic and bring it into the population?
Yeah, so that will definitely be our route to bring it to market quickly, but we'd like to go the regular FDA route as well, because if the EUA is pulled, you have to do a recall. So we'll probably be exercising both. Excellent.
So on the last note, so what's next then? What's next for you guys? Like, where are you now? You're over at the CDI, right?
Yeah, we are. So what's next is we are trying to work with school districts and workplaces as well to get them to understand, like, one, what their burden of need is. And if we can get this test to workplaces and schools and college campuses, and we can test people very quickly, it would be great to kind of see what that looks like in addition to clinics or urgent care centers or hospitals. Because we do think that we can empower people to use this without having a medical background. As long as you understand the workflow of it, pretty much anybody can use the test.
It's fantastic. Okay, so I believe we've come to the point in the evening where our guests have spoken, and we're going to open it up to the public, which could be a good or a bad thing. So do we have any questions? Okay, so I think this one is for Lazarus 3D there. So what has been your most complicated 3D print job to date?
Yeah, absolutely. So working with one of the doctors at Texas Children's Hospital, we actually developed a model that had the abdomen of a woman and a uterus inside of that. So the abdomen was airtight, the uterus was fluid filled. Inside of that, we had a fetus, and the fetus had a rare congenital birth defect. So the physicians were working on developing ways to go in and treat that defect before that child was even born.
And that surgery has never been done in an actual patient. So they were using the model to develop the procedure, to attempt or establish the protocols for how they would even go about doing such a procedure in utero.
So correct me if I'm wrong, but that's the work of Dr. Michael Belfort, right?
It's with
Dr. Belfort and Dr. Sandeep Keswani at Texas Children's. Yeah.
Superb. Yeah, wow, that is a very complicated print job there. But you guys power through, so excellent. And I think we have a question for Dr. Velamuri. Can you tell us about accessibility? Since you are a software company, how do you, for example, how do homeless people benefit?
Wow, talk about tough questions.
Yeah.
Yeah, well, it's a good question. So when we first built the system, this is something that we considered, and we thought about, like, for example, the homeless population in Houston. So Houston has wonderful people with an agency called Houston's Healthcare for the Homeless, or HHH. So we built a system that is deployed through their social workers, through the homeless population. So all of the homeless people in Houston, actually for the last 6 months, has been triaged exclusively through our system to quarantine or to hotels or to get testing or to get any sort of medical care that they need during this pandemic. And I'm pleased to say that we've prevented, through the work that HHH has done, we're just a tool that they've used, that their doctors and their nurses have done. We've prevented several super spreader sites among the homeless using software.
Oh, wow. That's fantastic. And I think we have another question for you, Sarma. Is everyone able to get tested for COVID-19? And this is in relation to your quick screen product.
Yeah, great question. So we work with public health testing agencies. And what we do is we enable that everyone can get tested that needs to get tested. And we allow the individual public health agency to determine what that qualification is. Short answer is yes, everyone can get tested.
That's fantastic. And I think I have a question here for Asma. So I think this could be a gamer that's on the line here, gamification. So they're asking about the use of your technology in VR and augmented reality headsets. And
that's a really good
progressing.
question. So the whole point of our technology is to make AR and VR obsolete, because with AR and VR, you are looking at a screen, and whatever is on the screen is obviously coming onto your retina. We're taking away the screen, and we have projectors that project visible images through visible light onto your retina directly. So if you're thinking about gaming, the whole point of it would be to have something that looks like glasses and you can wear it on your face like you wear glasses, move around as you need to, and you don't have to wear a bulky headset anymore.
I love the fact how you're talking about making AR and VR obsolete. It's it's hard enough to get an Oculus Quest headset these days, let alone a HoloLens for the price that's coming in, etc. You know. Okay, so any other questions? I believe that is it. Okay, well, ladies and gentlemen, the audience, thank you very much for your attention, and I'd love to thank my guests again for their time and for their commitment to the cause. You're absolute heroes in my book, and please keep up the work. Just keep going with it. Now, like moving ahead, just waiting for.
Thank you for hosting us too. Really.
No worries, guys.
Thank
Just
you.
stay safe, okay? All right. So, ladies and gentlemen, that is the end of our show. To leave on a very innovative power note, I'd just like to bring your attention to an event we're having this year. It's called Pumps and Pipes. It's on December the 7th, 2020, and I'd like to leave you with our video to leave you inspired. So again, thank you very much. Good night and goodbye.
Thank you,
Thank
Stuart.
you, Stuart.
Bye.
Bye, guys. Take it easy.
Thanks, Stu. Bye.
In the early 20th century, when two giants from distinctively separate disciplines collaborated on the development of an extracorporeal circulation device, I doubt they realized how extraordinarily unique their partnership was. At this moment, we are positioned in a fast-paced world where technology is advancing and globalization increasing, where distances get shorter, competition increases, and expectations are more demanding. A time when we need to make the best use of knowledge and look at each challenge from different points of view. A time for transdisciplinary integration of the sciences. A time when convergence innovation is needed most. Innovative leaders are curiously optimistic as they dare to take risks. And when leaders work together, the capacity to innovate increases exponentially. The world's most complex problems require convergence innovation. Through this approach, we have the ability to live longer, foster a better quality of life, and preserve this tiny rock we call Earth. It's why we are here, for the benefit of all.